Without any further ado, I'm going to invite Katherine Perdue to give her natChat speech talk.
Great, thank you.
I'll stop sharing my screen.
Yep. Share my screen. Okay. And did this work? Yes?
Yep, looks great.
Okay, amazing. Yeah, so thanks for having me. Thanks for the intro. I'm Katherine. I lead our neuro team here at Kernel. And today I'm going to talk about how we're using kernel flow for gaming applications. So just to get started, or if you're not familiar, so Kernel is a full stack neurotech company. And by that, I mean, we do everything in-house from chip design all the way through our neuro application development. We're founded in 2016, but we started working with optical brain imaging in 2018. So we've been at it for a little while now. We're based in Los Angeles, and we'd love for you to come join us if you're interested and have experience in this kind of work. We have openings on our neuro team. We also have openings in software, and we're looking for a really great game developer to help join us and expand in this area. So yeah, please check it out at the kernel.com site and see if you would be a good fit for working with us. Okay, so I want to start off just talking a little bit about our technology because it's very unique that it doesn't really exist in other places. So what we've built is this device that we call Kernel Flow. So it's an optical brain imaging system. And what it does is it uses TDF nears to measure brain activity. So if you're like most people and you don't know what TDF nears is, it's time domain functional near infrared spectroscopy. And I'm going to talk a little bit more about what that means in a second. But I'll just show you kind of what a technological advancement this system is. So our engineers have done a really amazing job. This is like kind of the technology is not new in itself, but it used to be in academia and part of these like huge racks of devices. And a whole system like this, you can see it next to a person here. That used to be for like a 4-channel system, or it's still used in academia like this. And what we have been able to do is to switch this over or to miniaturize the technology and make it all completely wearable. So what we have here is our Kernel Flow headset. So instead of having like 4 channels, this has over 1,000 channels. So it's a large technological advance that really kind of opens some doors in terms of the type of neuroscience that we can do. So the way that the system works is very novel, or it's not that common. What we do is we shine a very short pulse of light into the head, and then we use that to look at the tissue that's right underneath that source. And we measure it a little distance away using a detector. Now, if you've ever like put your hand on a flashlight, you see that it glows red, and that's because red light, and especially near infrared light, they travel really far through tissue, relatively speaking. So we're able to kind of leverage that and use the fact that light travels so far through tissue in order to get all the way down to the brain and look at changes in the brain measured non-invasively on the scalp. And the thing that we're interested in measuring, or what the measurement we get out of this system, is a measurement of brain oxygenation levels. So this is related to how hard the brain is working, and we get these maps that tell us how hard each area of the brain is working. They update more than 10 times a second. So we're able to get like a really good picture of how a brain's working and what those patterns are. So yeah, this is our system. If you have more questions, we have a recent paper out that goes into all the nitty-gritty details of how it was built, how we tested it, how we use it. But this is just a really brief overview of our technology. Okay, but what I want to talk about today, since our focus is gaming, is we want to know how video game expertise shows up in the brain. So video games are really interesting paradigm or experience for us. Video games are something that people do for fun, which if you've ever participated in a classic neuroscience experiment, you know that that's not usually something that people do for fun. So we're really interested in kind of figuring out more of these engaging ways that we can interact with the brain and how we can test the brain and how we can see the brain as it's growing, gaining expertise, changing over time. So this is our like interest in video games. So it's not just about fun, although it is about fun, it's also about expertise development. Okay, and then this is what we use. So we partnered with a really cool company called Aimlab, and they use neuroscience to help people become better gamers. So they're great collaborators, and this is their game. It's called Gridshot, and people play this for fun, which is awesome. The way that it works is so you're looking at this screen, and then these different orbs show up in different locations, and your job as the player is to shoot these orbs as fastly, as quickly, and as accurately as you can. You get a score, it goes up, and every time you shoot an orb, another one appears. So it's really fun and engaging. And that is what we're measuring the brain as people's brains as they're trying to do this task of moving around, making a plan about which orb they're going to shoot next, and do all of these things with this game. Okay, so the context of our study. So we have an open study right now that is exploring this, and we started to look at the data actually just for this talk. So we did a first pass of looking at this data. So we have our first 35 participants who played this, came in and did the study with this first-person shooter FPS game. We have participants, because we're interested in expertise and how that shows up in our games, we have our participants also tell us about their video game experience and their self-evaluated level of expertise at the video game. And I want to talk just for a second about how we're presenting the video game. We do still keep some of this classic neuroscience approach. So we have it broken up into two different conditions. So one condition is the grid shot condition, and that's like the game, that's the fun condition where you're shooting and you're making a plan and you're trying to figure out where the next orb is going to show up. But we also want to know that we're controlling for some of these things that might not be so interesting for us. So we have a control condition, and in this control condition, the orb shows up in the middle all the time. So you don't have to make a plan about where to go. You just have to kind of stay on task, click the button as soon as you see the orb show up. And then what I'm going to show you is an example of the difference in brain activity between these two conditions. So that's our kind of first or baseline thing that we look at, is just how brain activity is changing due to these conditions. Okay, so this is a lot. Hopefully it will move. Yes, okay. So just to give a brief overview of what this kind of map looks at. So this is a map of our brain activity or the overall brain activity. So this is averaged over all 35 participants. And what we're looking at now, so if it's red or this kind of bright, hot looking color, then that means that the brain activity was higher when they were playing the grid shot game than versus just clicking in the middle. And if it's blue, that means the opposite. So that means that the brain was working less hard when they were doing the grid shot game as compared to when they're just clicking. So the first impression that I get, or what I first see when I'm looking at this, is just, wow, there's a lot of activity. And this is really cool and very interesting. There's this kind of popular perception that video games like numb your brain, or they're not that interesting. And we found like this is showing the opposite, that video games are really interesting, that they exercise a lot of your brain, and your brain is very active while you're playing a video game. And some of these regions, I'll just call out a few as they zoom by. Actually, I'll wait till we go to the back. These regions match what we might expect to see based on the game. So, but in the back here, we have the visual cortex. So that's related to the motion of the dots showing up. We have some of the parietal cortex up here related to attention, staying on task. We have a lot here. So this part of the brain is controlling the right hand. So we are especially making this kind of planning for these motor movements, novel motor movements as they show up. So we're seeing a lot of, oh, and I think, yeah, we see some temporal activity, which is often linked to timing, precise timing. Oh yeah, and there's this area which we actually see reasonably frequently. I don't have a great explanation for it, but the best hypothesis that I've heard is that it's related to uncertainty processing. So if you're not quite sure where the next thing is going to show up, you might see more activity in this area. So these are just our overall results that we're using to kind of see what's happening in the brain while people are playing a video game. All right, and we have a few other measures that go along with this. First of all, we had this question of like, are experienced gamers actually better at the video game? Um, we ask people about their video game experience levels, but it's actually kind of hard to guess. I mean, you could guess maybe that people that play a lot of first-person shooter games might be good at this, but this is a slightly coarser measure. All that we're asking is just their self-reported experience with video games. And what we found is that indeed, people who reported that they have more experience in video games, they have higher accuracy, they have lower reaction times or faster reaction times, they hit more targets, and they're just overall more efficient at doing this behavior, playing the video game. So this is great. This gives us some confidence that our task is working how we expect, or that we are able to see something related to expertise or experience in our the behavior or how people are responding to this video game. This is a very coarse measure, or we're only looking at kind of these very blunt things. The video game, it actually has a very complex pattern of behavior, but we're really just starting off by looking at these very simple measures that just say, how good were they at hitting that target? Okay, so, and that leads to this result that we just found. So if we split all of our gamers into high performing versus lower performing, we do in fact see some differential brain activation. So this is in the prefrontal cortex, which is a region that's related to cognitive control. And we think that this is a very preliminary result, but I want to actually tie this to some of our questions that are still remaining. So as I mentioned, this is our first look at this data. We'll be collecting more of this data, but we just wanted to take a first pass and kind of explain how we're thinking about video games and with simultaneous brain measurements. And the first question that we had is if we're able to classify the skill level of individual gamers based on their brain activity. So that's getting back to this target or potential signature of expertise in the brain. So we think it would be cool if we were able to tell, from scanning your brain, like how good are you actually at video games? And then the other thing that I think is really interesting to explore, we haven't done this yet, but it's on our minds, is just can brain activity patterns either guide video gameplay or suggest training plans? There is a little bit of literature that suggests that as you get better at something, your brain activity pattern for doing that thing changes. So this could be a really interesting way to make the games more interactive and either wait or have a training plan. So as you get better, as they can tell that your brain is able to respond more efficiently to the game to make it harder. Or maybe if we can tell that, oh, you're getting stressed, or, this game is not becoming fun anymore, then take it down a notch, make it a little bit easier, make it a little bit more fun until you're ready to really go into that training and do a lot more. So we think that there are a lot of things that can be done with brain activity in video games. We're obviously just getting started and thinking about this, but there's a lot of really exciting applications, and we're really interested to see how we can incorporate brain activity into making the gaming experience more fun, and also as this kind of lab for understanding learning and gaining expertise. Okay, so I know that I'm at the last slide, but that's partially because I wanted to give a pitch for participating in this study. So we have, the study is open, as I mentioned. If you're interested in participating, and you're gonna be in the Los Angeles area, Los Angeles, all our sites are in Los Angeles, the general area, you can get the Kernel app. So if you have the Kernel app, you can sign up for any of our studies. We have a few that are open right now. One's looking at attention, one's looking at emotion, and then we have this gaming study that I just described. So I described approximately, or just like what happens, so you have the general sense. But one thing that I think is really cool and really novel about this study is that once you participate, you play this game, then we're able to show you your own brain activity right back in the app. So after you do it, you're able to see your own patterns and how your brain was responding to the task. So yeah, if you're interested, please feel free, get the app, check it out. And then the other thing that I wanted to make sure that I had time for is to really say thanks for the rest of the Kernel team. The Kernel team is very excellent. I know there's many familiar names here. And this is just our neuro and analysis team. We also have the awesome hardware team, software team that helped build the device, the system that allows us to collect this data. And I wanted to call out a few people in particular for their contributions to this talk. Julian and Andrew worked on the analyses. Howard worked on getting this task integrated with our system, the game, to make it work with our system. Austin worked on our recruiting to get our participants in, and Kayla made the very cool brain movie. Okay, I think I'm just at time. Thanks for your time, guys.